Alright, so example 2b, again, negative infinity to infinity. So the first thing we're going to do is break it apart. And, oh, well, that defeats the purpose. I'm going to break it apart at 0. Alright, and then I'm going to set up my limits. So that becomes a to 0. And this one becomes 0 to b. And this becomes pretty routine after a couple of these examples. Alright, so this one also has some not too tricky substitution going on. So I'll just jot it down real quick for you. Okay, so it definitely has the chain rule going on. If we make u be this exponent, the derivative will give us that x we kind of have out front. We'll just have to make sure to multiply by negative 1/2 to offset that chain rule. So this is really what we're going to be using our definite integrals with. So let's get that set up. We'll have the limit as a approaches negative infinity of, well, I'm going to use regular brackets here, negative 1/2 e to the negative x squared from a to 0 plus same thing from 0 to b. Whoa, that's not what I wanted. All right. So now we can actually set it up. And so it would be, I need to so I'm going to bring this guy to the denominator so that my brain can wrap around exactly what this is. So it's going to be to the 0 minus 2e to the a squared same thing over here, 2e to the b squared minus negative 1 over 2e to the 0. Alright. Let's make our lives easier. E to the 0 is just 1. So we're getting, what is that? Negative 1/2. This is really going to become a plus. And this denominator is going to just keep getting negative, but really large. But it's a large number being squared, so it really doesn't matter that it's negative infinity. This entire chunk is just going to approach 0. The same thing's going to happen over here with the b squared, and then this is going to become minus a negative or plus 1/2. So we have minus 1/2 plus 1/2, which means that it comes out to 0, of course.